So how are we going to start today's class? Well, nobody sent any questions, so that means everybody understands the material. So we're going to keep moving on, and we are going to move on, and I'm going to pull up the calculator. So everybody get your calculator out. And did we go over the calculator the other day on how to find the mean, median, and mode? Yes or no?
Yes.
Okay. Now I'm going to show you something different. I'm going to show you a key that we're going to use here in the near future. Now, the reason I'm going to show it to you now is so when I say, when we get there, you won't go, huh, what, huh? All right. And that is, I can't remember. I think it's under math, probability. There we go. No, that's not it. Hold on a second. I got to remember how to get there. Stat, calculate. Nope. Oh, second vars. Sometimes I get my stuff mixed up. Hit second vars. VAR is right above the tangent. VAR, that means variables. Second vars, and I want you to click on Normalcdf. Okay, now I want you to be familiar with that. So let's do it again. And you can put in your notes, area under the curve, z-score. That's what you'll put under your notes. Oh, and something else I did for y'all, and you're welcome. I'll go ahead and send it because I know there's some people out there that's too lazy to do it. So I went ahead and did this for y'all. I'll send this. Sending something in the chat. It'll go to the files. I sent that to y'all. And I'm going to send one more just in case. I tried to do it on a word processor and I screwed it up. So you might not want it, but I did it. I took a picture of it and I colored it for some of y'all that might want to just print that out. So can y'all look in the chat? Do you see the two files I just sent? Yes or no? Okay, for those of you that don't know what's going on, chat is right there.
Yes, I can see them.
Can you see them? There they are right there. So anyway, that's for those people that, it's a lot of work to actually do that. So it's a lot of work. Anyway, we're going to be dealing with z-scores on the normal curve, and we are going to find the area under the curve, which is called the probability, because these areas right here, they're under, percentages, and that's the same thing. Dadgummit. That's the same thing as probability. Percent and probability are the same thing under the curve. So 95% means 0.95 probability. So anyway, we're going to get there. And technically, I'll be honest with you, this section of probability should be in the probability section, but what they're trying to do, they're trying to transition over to the probability section, which is the next couple of sections after this test. So they're trying to do a little bit of transitioning here. Anyway, to make a long story short, we're going to be studying z-scores today. Now, have we haven't talked about z-scores yet, have we? A little bit, maybe? None?
Yes, you showed us the two formulas.
Okay. Did we go over the LBJ versus Shack?
Yes, we did.
Okay, good. Well, I'm going to tell you today, what about the area? Well, and I'm going to pull up my handy dandy whiteboard, and we're going to go over that right now, because there's two things for z-scores. There's two areas of z-scores. There we go. Z-scores. I'm going to just write down two sides to z-scores. One side is to compare apples to oranges. And we did that with LBJ versus Shaq. And you might see a question on the test that talks about an economics test versus a psychology test. And that is the same as LBJ versus Shaq. All right. Now, if you're talking about what's better, if you're talking about better, then we're talking about closer it is to 0. If you're talking about taller or wider or bigger or anything like that, that is toward the outlier. And I talked about that with the LBJ because they were asking who is relatively taller. A better grade would be closer to 0, a better grade. So if we get a chance to go over that question, somebody might send it in the homework. So that's one thing. Comparing apples to oranges is one thing a z-score does. The other thing a z-score does is find the area under the curve. Now, like I said, this really isn't statistics. This is more probability. But again, I think they're putting it at the end of the statistics to kind of make a transition over to the probability unit, which is unit 2 that we're going to be doing. You're going to be using Normalcdf on your calculator. Let me just rewrite that. Second vars Normalcdf. Now, there is a table. Before calculators, there was a table. Now, I'm going to show you the table, and I'm just going to show you how to use it, just in case you are on a standardized test and they don't give you a calculator. So here we go. Let me pull up the table right quick. And the easiest way, you can go to Google, and does anybody know what book this is? Who wrote this book? Can somebody look on the front of the book and tell me who wrote it? Anybody? Nobody has a book. Nowhere near in front of them. That's sad. Okay, so while y'all are looking for your book, can't remember who wrote it. Oh well. I'm going to pull up, and you can pull it up, z-score table. Anybody's found the author of the book? I'll have to go look it up. I can't believe out of however many students we got in here, nobody has a book in front of them. Nobody. But anyway, let me go to each text and see if I can pull up who wrote the book. We change books so often, and I teach out of so many different books, I don't keep up with who wrote it. Come on. Briggs. No. Wait a minute. I didn't know we were using Briggs. Wow. I didn't realize we were using Briggs. I thought we were using somebody else. Okay. So I'm going to pull up z-score table Briggs, because that's who wrote the book. And you see the tables right here. I don't know if these are Briggs or not. I don't see. I'm looking for Briggs. Well, I'm just going to show you what the table looks like. There's a table right there. And this is positive z-scores. See, all of them are positive right here. And this is 1.50. 1.50 plus 1 cent is 1.51, 1.52, 1.53, and so on. The 4 digits, and I want you to write that down for if you're looking at 4 decimal points, that's usually the area or the probability or the percentage. Okay, when you see 4 decimal points on a table, that means it's an area, probability. These are all the same thing. The directions may say find the area, find the probability, or find the percent. Okay, 2 digits, 2 decimal points is usually a z-score. So those 4 you see in the body, and I'm just showing you the table just because you might see it one day. These 4 digits, 4 decimal, these are areas. Now, if you move the decimal 2 places to the right, that'll be 92.79%. It all depends on what the directions ask for. Now, in this book, you'll see it written like this. Okay, let me pull that up, and I'm just pulling it up. These are negative z-scores all the way up to, see, I don't like the way they do theirs in this book because it's kind of confusing. Negative 3.5, negative 1, 0, up to 2. So they got all of them on here. They kind of skip the hundredths place. That's what I don't like about it. And here's one that goes from negative 2.1 to 3.5. So they give you 2, I think 2 right there. All right, and I'll show you how to use that in just a sec. Well, here's an example of what it says. The standard blah, blah, blah IQ test is scaled so that the score is normally distributed in a standard deviation. Now, I'm going to go ahead and tell you this. When you see normally distributed with a mean of 100 and a standard deviation of 15, when you see those words, I want you to write down in your notes, we're going to use this guy. Okay? When you see those words right there, normally distributed with a mean of 100 and a standard deviation of 15, you're going to be using this guy. You can call it the empirical rule. You can call it normal curve. You can call it the picture Hubert sent me on Teams. I don't care what you call it, but you're going to use this. You're going to have to draw it. And that's true throughout anything you do in probability and statistics. When you see those words, normally distributed with a mean of 100 and a standard deviation of 15, somewhere down the road, they want you to draw that curve. So they said 100, a mean of 100, and a standard deviation of 15. So I'm going to go ahead and put that in. Okay. So 100's right here. That'll be 115. That'll be 130. That'll be 145, right? And this will be 85. And this will be 70. And this will be what, 55 or 65? What is it? 55, I think. Somebody check my math. All right. Now, with the z-score, you can also put on the bottom of this too, and I'm going to put it in green. We got 0 here, 1, 2, 3, negative 1, negative 2, negative 3. Okay, so depending on what kind of question you get, if you get a question that says, what is 115? Well, then you can say, okay, 115, what's less than 115? And you'd add up all of these percentages up until you get to 115. Well, what's greater than 130? And you could say 2.35 plus 0.15, 2.5% is greater than 130, the score of 130. But what if they give you 116 or 117? Then you got to calculate it, and that's what the z-score formula does. All right? So when do you use the z-score formula? You use it when they don't give you an even score on the number line. Okay, down here are even scores, whether it be 0 or 1 or 130 or 145. But what if they give you something in the middle? If they give you something in the middle, they're not giving you an even score on the number line. So you've got to calculate that z-score. And that's what the formula is for. X minus X bar over standard deviation, or X minus mu over standard deviation, depending on if they asked for the sample or the population. Any questions so far? Okay, I think hopefully, I'm hoping that, you see the difference between the two. Yesterday, we saw who was taller, LBJ versus Shaq. We saw who was relatively taller. Over here, we're doing something a little bit different. Now, what are we doing? Well, take a look at that question. Find the standard score. Standard score is another word for z-score, so write that down. Standard score is another word for z-score. So if you see a question in your book about a standard score, then that is the same thing as the z-score. Find the standard scores for the IQ of 85, 100, and 125. So z sub 85 is equal to 85 minus 100 over 15. Z sub 100 is equal to 100 minus 100 over 15. And Z sub 125 is equal to 125 minus 100 over 15. And of course, this is negative 15 over 15, which is equal to what? Negative 1. That is a standard score that's on the number line. I'm sorry. This is a standard score on the number line. All these will be, that's equal to 0. 0 over 15 is equal to 0. That is a standard score on the number line. And then 125 be 25 over 15, which is equal to 5 will go into 25. I mean, that's 15, dork. Okay, so 25, 5 will go in there 5 times, 5 over 3. Y'all check my math here. That'd be 1 2/3, which is 1.67. But that is not on the number line. I just got a bad message. Am I breaking up or anything? I just got a bad message. Huh?
No, sir.
Okay, well, I'm going to turn my phone. I'm going to turn my phone off and I'm going to turn my video off just until those bad messages go away. The messages at the top that go, you have a bad internet network or something. All right, I don't want it to break up. So anyway, so this one is easy because all you have to do is look at the empirical rule and find the percentage. Okay, so 50% is at 0. We said that looked like fuel tank, half a tank. 0 is half a tank, so 50%. -1, if you look at -1, -1 is right here, and that is either 13.5 and 2.5, which is 16%, or on this side, it would be 84% if you add up all these percentages. So above -1 would be 84%, below -1 would be 16%. And see, that's -1 is right there, but see, 0 is right here. 0 represents 50%, 50% on this side, and 50% on this side. But what about 1.67? Well, 1.67 is right in here, and we don't have a way unless we know it's a little bit over half, but we can't divide this, and we can guesstimate it, but we don't know what percentage is at 1.67. So 1.67, we have no idea what the percentage is, whether it be below 1.67 or be above 1.67. We know that half of 13 is what? 6? Or half of this is 6.75 or something. I don't know. So half of this would be 6 and then plus 5. So we know by guesstimating that this area right here is around 11%. But that's just a guess. That's just a swag. Does everybody know what swag stands for? Well, that's a simple yes or no question. Huh?
Yes.
Simple, wild, attitude, guess. I have to say attitude because ass offends people. It's a donkey. Anyway, I don't say attitude. I just say ass. Simple, wild, ass, guess. United States of pansies, buttercups, and snowflakes. Anyway, I'm sorry. Simple, wild ass guess around 11%. But I have no way of telling this. So what I do is I hit my handy dandy calculator, or we did use the table. We could use the table. I'm going to show you. Let's use the table right quick. Let me go to a decent table because that table sucks. So I go to 1.6 right here and 7. 0, 1, 2, 3, 4, 5, 6, 7. 0.9525. 0.9525, and that's this area right here. In the table, that's 0.9525. So I'm way off. I don't know why I'm way off. I should be close. 0.9525 according to this table. 1.6, 0, 1.61, 1.62, 1.63, 1.64, 1.65, 1.66, 1.67. And the table always gives you to the left. Okay, so I'm wrong because we're only 5. I know why it's wrong. Because this ain't 5%. I always do that. These two together are 5%. This is 2.5. 2.5 plus 5 is 7. So I'm going to say around 7%. That's why it's off. And of course, you see by the by the table that it's going to be around 4%. I said around 7%. And that's why the simple wild ass guess is not good enough. So now we have to find this right-hand side here. To find this, we need to take 1 minus 0.9525, and that'll give us this right here. Because the area under this curve is 100% or 1. The area under the curve, total area under the curve, is equal to 1 or 100%, depending on what your book asked. If it asked for a percent or if it asked for probability, okay, or area. So 1 minus 0.95 is 0.0475. Which is 4.75%. And I said it was around 7. Well, I'm way off. Okay. Now, how do you do it on a calculator? Well, you take your handy dandy calculator. Which way do we read?
Left to right.
Okay, so if I want this side, and I'm going to put my arrowheads on here, I'm going to put my arrowheads in a magenta. This arrowhead down here is called negative infinity. And what is this arrowhead right here called? Positive infinity. Now you can't type in negative infinity and positive infinity, so we type in negative 9999 and positive 9999. Now, if I want the left-hand side of this line, and I'm going to color this magenta. If I want the left-hand side of this line, I'm going to go from negative 99999 to 1.67. If I want the right-hand side, this over here, this percentage, I'm going to type in 1.67 to 9999. So, Miss Ogilvy, since you're the only one that talks to me, which you want to pick, left or right? Okay, she went back to sleep. Anybody else want to pick left or right?
Right.
Right, Miss Ballou. Thank you, Miss Ballou. All right, so here I go. I'm going to pick the right-hand side. So that will be from 1.67 to 9999. So I take my handy-dandy calculator, and I hit second, vars, normal CDF, and I type in 1.67, and it's already got 9999 in there, and hit paste and enter. 0.0475. What do we get? 0.0475. Now that's with the table. I did this with the table, and I just typed that in, and I got 0.0475. How did I know to do 4 digits? Well, it's asking for the area. Area is usually 4 digits. I told you that right here. Area, probability, or percentage, I usually carry at 4 decimal points. All right, so let's do the other side. So second, vars, normal CDF. I'm going to go from negative 9999 to 1.67. And it should be 0.9525. That's what the table said. Go to paste and enter. There it is, 0.9525. And that's how you use the z-score to find the area under the curve. We're going to do another one, don't worry. Any questions on normal CDF and how to use the calculator? You've got to read the number line, you got to plot it, and then say, okay, what's the question asking for? Is it asking for the left side of 1.67, or is it asking for the right side? Greater than or less than? So let's look at another problem and see if they give us another one. Okay, I want you to do this one. I'll make it a slideshow so you can see it. There we go. Cholesterol level, okay, blah, 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 blah. Mean of 178 and a standard deviation of 41. So draw a picture. The first thing I'm going to do is draw a picture because I can't do anything unless I draw a picture. Some of y'all are going to try, but you can't. So I'm going to put 178 in the middle. And I got to use my calculator because I don't want to mess up. So I'm going to use my phone. 178 plus 41, 219 plus 41, 260 plus 41. I know what that is. 301. 178 minus 41, 137 minus 41, 96 minus 41, 55, and I'm going to put my z-scores on there also. 0, 1, 2, 3, -1, -2, -3. Now, for those of you that can't see, here is what I just did. Notice I haven't even read the question because I don't need to read the question. I need to get my picture first so I can tell what's going on. And the number one thing that students don't do, they don't draw this picture. Therefore, they don't know what the heck the question's asking. So I would be very, very, motivated to make sure you include the picture in your method, okay? Because it's going to be confusing if you don't. Unless you're just, the person that invented the empirical rule. Miss Ballou, you talk to me. Have you taken probability and statistics in high school?
Yes. And I took.
Did y'all go over this?
Yes, sir.
Good. Well, some of y'all have never seen it before, so we're going to go with the feeling that, some of y'all haven't seen it before, but you might have forgotten. All right, so I'm going to go back to the slide. In what percentile is a 20-year-old woman with a cholesterol level of 190? So they're asking what percentile. So 190, where is 190? Well, we go back to our picture. Where is 190? Well, 190, I'm going to take my green, let's see, since it's in the green area, I'm going to take my green highlighter and our green marker. 190 should be right in here. Half of 41 is 20. So 20 added on to, that'd be 198 right there. They wanted 190. So I'm going to take my handy dandy, I'm going to make 190 be somewhere right in there. Now, there's a left-hand side and there's a right-hand side. Now, we got to turn 190 into a z-score so we can punch it into the formula or do the table. Now, let me go ahead and tell you this right now. Some of you have newer calculators. And with the newer calculators, you can type in a mean of 178 and a standard deviation of 41 under normal CDF. So if you go to your normal CDF and you can type in 178 and 41, you do not have to do the conversion to a z-score. Now, I want everybody to write that down, please. If you have a newer calculator, how do you check it? Well, if you can type in 178 and 41 at the normal CDF, then you don't have to do what I'm fixing to do right now. This is for your older calculators that can't change the mean and the standard deviation. The older calculators, the mean is equal to 0 and the standard deviation is equal to 1, and you can't change it. So decide which calculator you got right now, because that's the way it is. So if you have an older calculator, we're going to have to change this to a z-score. We know it's going to be between 0 and 1, so it's going to be, I would say, around 0.4. So 190 minus 178 over 41. So I'm going to take my handy-dandy calculator, and I'm going to do 190 minus 178 and divided by 41. I said around 0.4. Okay, I was off, 0.3. But we need 2 digits, so that's 0.29. So if I want the right-hand side, I'm going to go from 0.29 to, let me use my magenta again, 9999. Or if I want the left-hand side, I'm going to go from negative 9999 to 0.29. Now, since the calculator just said percentile, it just wants a percentile. So I would go from the left because that's the way we read. So first thing I would do, I would type in second vars. I'm going to do it like the old calculator. Okay, I think I can go in and change this. Yeah, I could change this to 141. See? And see, that's a new calculator. I'm not going to do that because if you got a new calculator, you know how to do it. You type in 178 here, and you type in 41 here, and you type in negative 9999 to 190. That's if you got a new calculator. If you got an old calculator and you can't change these two, the stays 0 and 1, like that, you can't change it, then you're going to type in 0.29 right here. Do you get the same answer whether you use the old calculator or new? You get the same answer. And the answer is, I'm gonna guesstimate. We know this is 50%. We know that line right there is 50%. And we know 0.29 is half. 0.24 would be, let's see, 34, 32, 8, 7. I would say it's around 57%. I'm going to go around 57%. Now, that's a guesstimate. All right, let's see what it is. 0.6141 is around 61%. So your answer, the answer to this question is it's around the 61 percentile, 61.41 percentile. 61.41% or 0.6141 probability our area is 0.6141. Remember, area and probability is a decimal. Percentage is a percentage. So let's see what the answer is. Let's see what they got. 0.29. They're doing it old school. Okay, and they rounded to the whole, they rounded to 62. And that's fine. You can round to 62. Depends on what the directions say. Now let's see what B says. What cholesterol level corresponds to the 90th percentile? Now this is bisaccharids. All right, let's draw a picture. Well, I can't get my curve. There we go. All right, somebody tell me where the 90th percentile is on this curve. Well, while you're figuring, I'm going to put, what's the mean? The mean is 178. Let me copy my numbers right here. Let's see, this is 178, 219, 260, and 301, and 137, and 96, and 55, and 0, 1, 2, 3, -1, -2, -3. Where is the 90th percentile? Well, what do we know this is right here in the middle? What is this? Where's my black
50%.
pen? 50 percentile. You know, if you add all four of these numbers up, and we read from left to right, the curve reads from left to right. This is empty. This is 25%. This is 50%. This is 75%. And this is full. So you know it's going to be on this end, because if your fuel tank is 90% full, it's going to be right in here. So we know it's going to be right in here because that's the way we read it. So that's 50%. What's 50 plus 34?
$84.
So this point right here is 84%. So how much more do we need? We need 6%. So 6% would be about what of 13.5? Half, Hubert. That's right, class. So they're wanting to know what number, what test score, and we know it's between 219 and 260, is at the 0.9000 90th percentile. Now you're going to go backwards here. Now, if you use the table, I need to hurry because some of y'all are going to start convulsing. If you use the table, I'm going to go back to the table here. I've got to find 90th percentile, and I know it's positive, and it's between 1 and 2. So I know it's around 1.5 or somewhere around there. So I'm looking for 1.5 as far as the z-score. Well, I don't see 1.5 on here. I see negative. I don't see, there's 1. Z-score, I don't understand how this thing reads. Let's look here. 1 point, here we go. Oop, there it is, 1.3. Now, I don't like this Z table because that don't give you a lot. That's 0.32 over 90. So that's why I tell students to use a calculator. If you go to the Google table, the one that's worth something, let's go find 90. What number is closest to 90 in here in the body? Right here. What's closer, $89.97 to 90 or $90.15? What's closer? $89.97 or $90.15. What's closer to 90? Anybody? 89.97. So that's representative of a z-score of 1.28. So by the table, we've got 1.28. That's a z-score. Now, I don't have a test score here. So how do I change that 1.28 into a z-score if I'm doing it by hand? X is equal to Oz plus mu. Write that down. This is if you're doing it by the table and by hand. X is equal to, the standard deviation is 41. The z-score is 1.28. And 178 is mu. And somebody crank that out for me and give me 2 decimal points. I'm sorry. Yeah, 2 decimal points because it's a score, like these test scores down here. I say it's going to be probably, what's half of 41? Half of 41 is 20. I'd say it's going to be around 238, somewhere around there. What does it come out to be? I got to hurry.
230.48.
230 point what?
48.
230.48. And that you could argue that this bumps up to 231. So a test score of 230 or 231, depending on what the directions ask you, rounding. So a test score of 231 represents the 90th percentile. Now that's how you do it if you are using the table. Now, here's the good part. Second, VAR's inverse norm. Second VAR's inverse norm and type in 0.9000. I tell students to use 4 digits because you're typing in an area. Get used to those 4 digits. Second, you turn it on first. Second, VAR's inverse norm. Now, if you have a newer calculator, you can change this area is 0.9000. Now see, I can change that to 178 and 41 if I have a newer, and this is a newer calculator. But if you don't have a newer calculator, you got to get the z-score, which is 1.28 right there, and do that right there. Okay. If you do have a newer calculator, you hit second VAR's inverse norm, 0.9, and then you would type in 148 or 178, sorry, 178, and then 41, and then it will give you the score without figuring, 230.54. So by inverse norm, if you got a newer calculator, you get 230.54, which is still 230 or 231, depending on what they ask for. Now, the table is not going to be as accurate as a newer calculator. The table is always going to be a little bit different from the calculator, but the answers on the test and the homework have a tolerance, since it's in a class. The answers they have a tolerance of about 0.02, 0.03. So that 230.48 and that 230.54 would be inside the tolerance of the answer. But as always, and we'll talk about this when we go through the test, if Miss Ballou put 230.48 on the test and the answer is 230.54, she would see me after class, and I would look at it, and I would give it to her, because all she would have to do is say, Hubert, I had to do it by the table. And if she told me that, then I could see that there's a difference. But chances are they're not going to ask you for 230.48. They're going to say round, and she would round that, I would, to 231, and this is 231. So chances are I'm going to give her the credit either way, okay, if she comes see me after class. We'll talk about that when we go over the test. Any questions? All right, now that's pretty much, now I know I'm over. That's pretty much it. That's 5 and 6, or whatever sections we're on, okay? So that means Friday, what is Friday? Friday, if I don't get any questions on the homework, like I haven't been, y'all haven't been sending any, I'm either going to do homework questions Friday, or I'm going to review the test. One of the two. So make sure you get that homework done, because we are closing in on homework date. Any questions? Those of you that need to leave, go ahead and leave quick, because I've already taken the roll. Is there any questions? Anybody got any questions? I'll go over everything about the test when I go over it. How many there's going to be, how much time you have, all that good stuff. Any questions? Y'all get out of here then. Have a good day. See y'all Friday.
Thank you. Have a good day.
All right.
Have a good day.
I'll try. Y'all do the same. See y'all.